In this video, we're going to then trying to do all of them on your own first. And then once you're done or you hit a spot where you're stuck, then you can watch this video and check your answers when you're done as well. So in question number 1, we have our balanced equation right up here. And our question is, how many moles of KCl are produced when you start with 6 moles of KClO3? So we're trying to get KCl, and we are starting with 6 moles of KClO3. So if we were using this, we're going to be going from moles A to moles B. So this is what we would be plugging everything into. We would start with 6 moles of KClO3. And then we would multiply by moles of B on top. So we think KCl, we're only going to take the coefficient. So it'll be 2 on top. And then coefficient in moles A on the bottom. So it would be 2 on the bottom. So if you did that math, your answer would be 6 moles of KCl. So that's how you would solve it using this. If you want to solve it using the batch method, you can think, I'm starting with 6 moles of KClO3. How many batches can I make? So you're starting off with 6 moles, and you would divide it by 2 there. And that would equal 3 batches. You're making 3 batches of this recipe here. So if you're making 3 batches, and each batch you get 2 KCl, then you would do 3 batches times 2 KCl, and you get the same exact answer, 6 moles of KCl. So I just wanted to give you an example of 2 ways you could solve it. Both you'll get the same answer, the correct answer. Moving into question number 2. How many moles of KClO3 are needed to produce 8 moles of oxygen? So here we're starting with 8 moles of oxygen. That's what we're given. And we're trying to get to KClO3. That'll be B. So here I could write it out. 8 moles O2 and then I just have to, multiply, put my coefficients on top and bottom. On the top will be what I'm trying to get to. So my coefficient on KClO3 is 2. And my coefficient on the bottom will be my coefficient in front of my oxygen. So it will be 3. In this case, if you do all this, you'll get about 5.33 moles. Let me make sure I'm doing this right. 16 divided by 3. So that would be 5.33, yeah. 5.33 moles of KClO3. If we wanted to do the batch method, this one's a little bit trickier because it's not a whole number of batches. You're producing 8 moles of O2, and each batch gives you 3. So you could think of it as 8 moles, 3 per batch. So that would be about 2.67 batches, 2 2/3 batches. And then from there, we're making 2.67 batches. And we are going to need 2 KClO3 for each batch. So it'd be 2.67 times 2, and it'll be about 5.33 mole KClO3. So again, you don't need to know both of those ways, just as long as you can do one of those ways and find that answer. We got one more problem like this. So let's take a look at question number 3. In this case, if 5 moles of KCl are produced in the reaction, how many moles of O2 are produced in the reaction? All right, so in this case, they're giving us how much KCl was made. We're trying to figure out how many oxygen was also made. So if we are doing the math, we start with the amount of moles they give us, 5 moles KCl. Now we got to put that ratio here. So again, we're busting this out. We got to put the coefficient of what we're trying to get on top. We want to get oxygen, so that coefficient would be 3. Then on the bottom, our coefficient of what we start with, KCl is 2. So in this case, 5 times 3/2 would give us an answer of 7.5 moles O2. If we want to think about this as in terms of batches, this will be the last one I do in terms of batches. We're starting with, we made 5 moles of KCl. So we got to figure out how many batches did we make if we made 5 moles of KCl. So each batch we're making 2 moles. So we could divide it by 2. And that tells us that we did 2.5 batches. So if we made 2.5 batches of this recipe, that means our oxygen would be, we'll have 2.5 times, we make 3 oxygen for each batch. So 2.5 times 3, and that should equal 7.5 moles of oxygen. So again, you're actually doing the same thing here. You could see when you're doing it this way, you're dividing by 2 and multiplying by 3 in the same step. So you're really doing exactly the same math. It's just 2 different ways of thinking about it. All right, so problems 4 through 7 are all molar mass. I'm pretty sure most of you guys are experts, but this is extremely important. And if you're not an expert, I want to make sure we can all do this. So bust out your periodic tables. And let's get started on this. So our first one, number 4, we're trying to get the molar mass of C3H8. That would be propane. So we need to find the mass of carbon and the mass of hydrogen. So let's zoom in here. And the mass of carbon is about 12.01. And we have 3 of them. So let me make sure you can see this. So we have 3 carbon, and the mass of each of them is 12.01. So we can multiply those together. And then hydrogen, take a look at the mass of hydrogen. It's about 1.01, and we have 8 of them. So it'd be plus 8 times 1.01. So I do not have my calculator on me, so let's just kind of do it step by step. So 3 times 12.01 is 36.03, and 8 times 1.01 is 8.08. And if you do that, our molar mass will be roughly 44.11 grams per mole. All right, so the next one we're finding is O2. So this one will just be 2 oxygen. So we'll multiply whatever the mass of oxygen is by 2. And you can find it right here. 15.9994. We're going to round that up to 16. And our molar mass of oxygen is 32 grams per mole. Next one, carbon dioxide. So in this one we got carbon and 2 oxygen. So we've already got the molar mass of carbon, if we remember. It's 12.01, and we just have one of those. So 12.01 plus, and we have 2 oxygen here, just like last time. So 2, and if you remember, oxygen has a mass of 16. And that'll give us our answer. Let's do the math. 12.01 plus 32. It's going to equal about 44.01 grams per mole. Lastly, we got H2O, which is water. And again, we've already found the mass of 1 hydrogen. That's 1.01. In this case, we have 2 hydrogens, so we have to multiply that by 2. And then in water, we just have 1 oxygen, and the mass of that is 16, so we'll add 16. So it'd be 2.02 plus 16. That would equal 18.02 grams per mole. So we are going to need all of these molar masses. Let me put boxes around them. We're going to need all of these molar masses to help us answer questions 8 through 10. So we're going to need these for those questions. All right, so for these questions, I got our balanced equation right here. And question 8 says, if you have 100 grams of C3H8, what is the mass of oxygen you need for the reaction? All right, so you may be wondering, why do we have, so far we've just been going moles to moles, and we've just been opening these 2 flaps. Why do we have these outer flaps? It's in case we have to convert our mass to moles first, because when we are working with these coefficients, these mean moles right here. So 1 mole of propane and 5 moles of oxygen react together to form 3 moles of carbon dioxide and 4 moles of water. There's no spot to stick grams up there. So if we're given grams here, 100 grams of C3H8, that's okay. I mean, they're giving us grams. We need to now convert that to moles. And our answer, what they're asking the answer in, is also mass. So then once we do our conversion here, we have to go from moles to mass still. So this will be a 3-step problem. So our first step, we have our mass of propane here, but we need to convert it to moles. So what do? You flip this up. It'll tell you exactly what to do. We need to divide by our molar mass to get the moles of propane. So let's start off by doing that. We have 100 grams of propane, C3H8. All we have to do is divide it by our molar mass. So divided by our molar mass of propane was 44.11. Grams per mole. And I need to grab a calculator really quick so I can do this. All right, got the calculator. So I'm going to plug this in the calculator. 100 divided by 44.11. And 100 grams of propane is equal to about 2.27 moles of propane. So now that we have our moles, we need to now convert that into moles of oxygen. So we can do that by doing this, just taking the coefficients. So we're going to multiply it by those coefficients here. So if we're reacting 2.27 moles of propane, our coefficient on oxygen is 5. So we're going to put 5 oxygen up top. Our coefficient on propane is just 1.